Good morning, good afternoon, and good evening. I'm Ken Martins, the Global Practice Technology Leader for Stantec's Industrial Water Group. And I'm pleased to moderate today's webinar on water reuse applications across industries and advanced economies. This is co-hosted by IWA and WATEREUSE.org. Next slide. So again, it's being hosted by IWA's Water Reuse Specialist Group. It's the third of a four-part series on the road to China 2023. The first two seminars, one in February, was on water reuse in the United States and on the trends on the rise of the use of that. And the second one was in April on water reuse and perspectives from emerging countries. Then there's today's, and then the fourth and final will be in July on progress towards microbiology safety and potable water reuse. Next slide. Oh, skip one. There you go. So the IWA Water Reuse Special Group makes substantial contributions on elements of water reuse, both international, regional areas. They support preparation of conferences, workshops, and webinars like this, and publications, etc. And the really goal around is develop communication and documentation, development of technologies for further acceptance of water reuse across industries. Please consider joining IWA Water Reuse. There's a link at the bottom of the slide. Next slide. So the Industrial Water Reuse Industrial Commercial Committee of Water Reuse, I chair that committee. We're a nonprofit dedicated to advancing laws, policy, funding, and public acceptance. Established in 1990, we have members in 38 states, District of Columbia, and 11 countries. Again, like IWA, they host conferences, promote networking, membership, and their goals are in national advocacy. Our committees supported testimony to US Congress, for example, also state level, and various forms of communications. Again, all of that centering around improving the acceptance of development of technology and acceptance of water reuse. Next slide. So the conference in Chennai, India is in January 2023. They are accepting abstracts until May 15th, so that's just 3 days from now. So if you're interested in presenting, please submit an abstract to iwareuse2023.com and go through that process. I think you'll find it quite rewarding. Next slide. So some housekeeping. The webinar is being recorded and will be made available on demand on the IWA website. The prior webinars that we discussed earlier, those are also available. They'll be with presentation slides. Now, please note for today, the speakers are responsible for securing their own copyright permissions. And any opinions and hypotheses and conclusions, etc., are the responsibility of those speakers and don't necessarily reflect IWA's opinion nor WaterEUse.org's opinion. Next slide. So there's a navigation bar on the bottom of your screen, and the raise hand function will not be used today. The chat box is intended for IWA staff. If you're having problems with the webinar, audio, video, or some other issue, or just have a general question for IWA, use the chat box. The Q&A box is for questions to the panelists. And we will answer some of these during the discussion after that panelist is done talking. But we'll also be answering some of these during the Q&A session at the end of the presentations. When you do write your question, please indicate which panelist you intend the question for. And if you don't recall the name, you can just refer to them as like Patrick the DuPont representative or Kyle the R3 representative, etc. Okay, next slide. Okay, so today's agenda, I provided these introductions and a few more coming up. And then Patrick's going to do one on reuse of municipal wastewater for cooling water applications. I really like this presentation because it's heavy industry focused. And it certainly provides one of the options for the greatest amount of water reuse. Then Laurent Hebert is going to present on rainwater harvesting and reuse in industrial facilities. He's going to be based around projects in primarily in Mexico City. And then finally, Kyle Gronowski is going to present on expanding reuse through financial and tech innovation. And so I really like all three of these, and that we cover heavy industry, we cover sort of manufacturing industries with Lawrence, and then Kyle on financing and selling the project. Then after that, we'll have a poll question, and we'll give about a minute for that, go into our Q&A, where we'll have some, we'll answer questions live. Then we'll have some final closing remarks. Next slide. So here we are. Here's our 4 presenters for today. Next slide. All right, so we have learning objectives. 1, we want to understand current and emerging industrial reuse practices, fit for purpose treatment, identify elements needed to make business case for industrial water reuse. I think Kyle's presentation will be very, very poignant there. And then 3, gain an understanding of the current state of technologies and examples across North America. And all these, of course, can apply worldwide. Next slide. Please feel free to share your thoughts on social media with these tag or hashtag signifiers. You know, you can, for example, talk about, you know, why is water reuse important? How does it affect you? Contributions to meeting the 2030 agenda, etc. Next slide. So what is industrial water reuse? I'll break it down to 4 levels. There's in-process industrial water reuse, or you might call this tank side treatment. And that'd be in applications where there's a process of some sort and the water or aqueous solution is being, it's being dirtied in some way. And you might allow reuse and continued reuse of that water beyond what you would do without that side treatment. Then the next level might be within the fence line of an existing facility that you might have a wastewater plant where the water is treated to a level where it can be reused. Never used often is either things like cooling towers, or sometimes this could be used for other applications, but cooling is a very common way. Finally, there could be regional parks, sort of a 3rd level, regional parks of industries that might have a common wastewater plant. Now, all those individual facilities within that regional park could have their own industrial reuse within their fence lines, but then the centralized plant, industrial water treatment facility, could treat it to such a degree that it could allow additional reuse. And then finally, there's the 4th level, the largest level, if you will, in more the municipal government scale, where it might take municipal sewage, treat it to a level that allows it to be reused by industries, or in some cases for irrigation purposes, etc. So what sectors are practicing industrial reuse? Well, really all these are. You'd be hard pressed to name one that doesn't have some type of reuse. And I can personally provide examples in all these different industries where they had reuse. So I mean, things as crude as mining or as specialized as pharmaceutical. I've personally worked on projects where we've had industrial water reuse in all of those. Next slide. So let me introduce Patrick. Patrick has over 25 years of focusing on and understanding the challenges of the market and customer and bringing innovative solutions with tangible values to meet their needs. He has a broad range of municipal and industrial water experience, including municipal wastewater, potable water treatment, food and beverage, mining, power, and pulp and paper. And during his time in the water industry, he's held various leadership roles in NALCO, GE Water, Evoqua Technology, in his current role as commercial excellence leader at DuPont Water Solutions. So very broad base. So I welcome Patrick. He's going to talk about that larger, heavy industry scale. Thank you.
Thanks, Ken. Appreciate that. And hopefully everybody can hear me and see me okay. Good morning, good afternoon, good evening, depending on where you are dialing in the world. You know, I'll take about the next 10 minutes or so, and I promise to try to keep us on time. But take the next 10 minutes or so to talk about how we've had some experience, and ultimately we've got opportunity I'll say globally in the industrial marketplace to make wastewater or water reuse cool again. And so what I'll do is I'll really lay the groundwork a little bit in terms of the what it is when we think about water reuse. What are some of the elements, the considerations? Ken touched on some of those. At the same time, I'll give it some specificity. It's sanitized to some degree, but ultimately, I've got a pretty cool example of something that the DuPont organization has done with a customer. I've got another one I want to sneak in. I think it speaks to the challenge of the complexity, which I think is a little more profound within a refinery space. And then I'll wrap up from there. So with that, feel free to go to the next slide, but let me just kind of lay the basic groundwork, right? We talk about water reuse in the industrial space. I think some of you may have heard that referenced as R3. I think Kyle, who you'll hear from soon, can appreciate the reference to R3, but typically R3 is a lead in to define what exactly are we talking about. Are we talking about reducing water consumption, reusing water consumption, recycling water? In the end, the reduction I think is pretty straightforward, right? Anyone that's walked the lines at a refinery or a paper mill appreciates the value in identifying leaks and addressing those in a meaningful way. The reuse within a facility is, I think, defined by a lack of treatment, meaning that you take the waste effluent from one process and then recycle that at either in another process or other, right? I'll just, I think of like the brown stock washers within a paper mill. That rinse water, the effluent rinse water coming from that last stage is used to rinse the slightly dirtier stage preceding that, and so on and so forth. So it's kind of this this internal reuse per se, but really where I'm going to focus today is around recycle. And I will do my best not to mix up the terms. I'm human, so I may do it. But ultimately, what I'm talking about today is recycle. I think a lot of what we're going to talk about today across the sessions is around recycle. And that it ultimately is defined as having treatment, right? So it's treating the effluent from one process to be reused in the same process or somewhere else. Or ultimately, as we look at the opportunity, and I'll showcase the opportunity where we used municipal wastewater from a neighbor, you can use that water, treat it, and send it completely outside the fence line. And so, what we see on the screen is, before I even get to that, let me just say, just a little bit of accolades for this audience, who I think are really oriented around the industrial. Admittedly, I think a lot of times when we talk about, for the Water Reuse Association, we talk about water reuse, the mind goes immediately to a municipal facility. And I don't think we get enough credit on the industrial side, and as much as, at least within the US, about 50% of the water recycled is done within an industrial facility, or at least done in tandem with the industrial facility. So I think the content we'll share today is just the tip of the iceberg on what we have done and what we're capable of doing within the industrial space. So with that, just the slide that I'm showing here is not comprehensive. Obviously, it's not something that's ready for a stamp or is going to be prepared for a stamp, but it's really to kind of set the tone for the conversation, right? You think of within a refinery, there's a lot of different ways we use or demands for water, right? Certainly there's utility water, cooling tower makeup, cooling water in general, boiler feed water, process water, service water, fire water, right? You think about within a refinery, fire water is key to the safety program. I think anyone that's had a fireproof phone, a cell phone, appreciates the sensitivity for safety, especially in that type of a facility. But then also, if I shift from the blue to the purple, just highlighting some potential sources for unconventional water supply, right? Not just thinking of it as wastewater, but think of it as unconventional water supply. And ultimately with the green, showcasing some, probably for this audience, fairly obvious opportunities for us to reuse, or to stick with the terms I've laid out up front, to recycle that water, treat it, and then bring that back to the front of the process. So with that, if you don't mind going to the next slide, same content, really, it's just on this slide, what we're looking at is I'll say, foregoing any debate, because I would imagine with this audience, if I put real dollars per kgal or dollars per cubic meters, I'd open up a flurry of questions and opinions. But just orders of magnitude, what I'm intending to show on this slide is just, the lower capital cost, the lower OpEx rate related to, I'll say, a simplistic, though it's not simple, but a simplistic clarification filtration mechanism, to something that's certainly going to be more energy intensive, as well as more complex in terms of operation with CIP, et cetera. But think of the contrast of that of an RO system, and even the usage of UF and RO technology to properly recycle the water. So I'll pause on that, just because we'll get back to a little bit more and just push to the next slide, if you don't mind, and I'll start talking about the fun stuff, the actual example. So next slide, please. So again, typical refinery, and just for in respect to the relationship we have with a customer, I'm going to be a little high level on some of these, but certainly welcome any questions, and I'll do my best during our Q&A or even in a follow-up to provide some additional insight where I can, let's say, stay on the up and up. But typical refinery, where the refinery, depending on the complexity, depending on what type of crude slate they're operating on, pardon me, they're going to use a different volume of water, right? I would say that they're typically going to use anywhere from, let's say 0.3 to 1.3 barrels of water for every barrel of crude refined, right? And again, I think anyone who spent enough time in a refinery can probably appreciate how that can range, and potentially could go outside of those spec limits that I called out. But ultimately, the water quality requirements can vary from one refinery to the next, right? One could argue that no refinery is made like another, but fundamentally the use of the water, and I'll zero in on the use of water for boiler or ultimately for cooling tower makeup. But the use of the water is ultimately treating to the need, right? And as we're treating to the need for boiler water, and really I'll frame it as cooling tower water, it's all about how much can we optimize our cycles of concentration within that cooling tower, specifically an evaporative cooling tower. And they think about the water quality. It's not about just eliminating any salts from that water, right? I think we'll get into this a little bit, but the components of maintaining the chemistry of a cooling tower system is delicate. It's a bit of a balance, but in the end, ultimately what we want to do, and what limits the cycles of concentration, is the hardness and the silica. Those are the two bad guys, not the only bad guys, but that's really where we oriented. And so to speak to some specifics of this installation, this is a refinery that was in growth mode. And in order to meet this growth mode, obviously they had a large capital budget to grow, but what they didn't have was a large, let's say, water budget that they could go to. They had limited draw that they can take from their existing sources, and so they went to a neighbor. The neighbor that was in very close proximity was a wastewater treatment plant that ultimately they looked to take enough volume to produce about 500 GPM of additional makeup water capacity for an expanded bank of cooling towers. And so if I can go into some detail on the next slide, there's two components. And it wasn't clear. Next slide. Thanks. Thinking about it from a planning standpoint, I think any of us that have looked at or contemplated a water reuse project, we want to look at availability. We want to look at the seasonal demand, even seasonality of the supply that we may potentially tap into, as well as the quality and even the physical characteristics of that supply. But ultimately, it taps into the overall complexity of the refinery. And so, really, what as we approach this project, as the team approached this project, we looked at the logistics of the of the quality and quantity of the water that we would get from the neighbor, the municipal wastewater treatment plant, and just even getting into how much is it going to cost us to pump it from here to there. What kind of piping do we need to lay? What kind of infrastructure do we need to put in place? Does it need to go over a road, under a road? How do we maneuver that? Right. So these are all things that we had to take into consideration. But really, it came down to the return on investment, and ultimately, it came down to, does this set up to meet our future demands for this phase and the likelihood of future phases down the road, future expansions down the road for this refinery, which fortunately the answer was yes. And so, again, if we look at the treating to the need in this case, we're going to take the wastewater from the neighbor, treat it, and use that for makeup water. So think about it in terms of the treating to the need. We're looking at a UFRO operation. So if you can move to the next slide. And I think as we look at that, there's a complexity that comes along with that, right? Operators who haven't operated a UF system, have not operated an RO system before, it's not just change. There's some real sophistication that goes along with that. One that I think most operators are very capable of. But in the end, what we did is we designed a UF system that had a tight footprint using a PVDF membrane that was small in footprint, pressurized UF modules, but ultimately would take that permeate and remove the suspended solids, right, to bring those down to less than 0.05 part per million. And then from there, set the stage for the RO to do its job, but to basically bring some pretty brackish water and bring that down to a TDS of less than 100. And ultimately, the design there was to set us up to optimize the cycles of concentration within the cooling tower. So on the next slide, what you'll see are some details in terms of the specs, and really, I'll say, a design basis and summary that we use to figure out what flux rates could we operate at, how hard can we drive the RO system, et cetera. In the end, I think these are fairly typical parameters that many of you, I imagine, have seen coming from what would be the unconventional source water of municipally treated wastewater, tertiary treated wastewater at that. But what we looked at was ultimately a UF system that gave us 90% recovery, fairly healthy, right? We don't want to recycle water to only to give it up in the process. But as we move forward to the RO system, we used a conventional RO approach in this case, but that gave us a design recovery of about 80% using a 16-8-4 element configuration in the RO design. And so I'll just speed up here a little bit for the sake of time. But if I can go to the next slide, some considerations, and I'll really focus in on the front, the first bullet here, which is biological. The key thing to think about when, first off, you think about the pillars of a good water treatment program for a cooling tower, right? There's three legs to the stool, right? There's biological control, there's scale control, there's corrosion control. Biological, that leg of that stool, when you're talking about recycling municipal wastewater, that leg is very important. And it was very much important with this customer. So it was key that we were diligent and we put control mechanisms in place, ORP monitoring in place to maintain a free chlorine residual in that makeup water of 0.5 to 1 ppm, in not only in the makeup water, but also in the recycling water, and ultimately measured in the blowdown water for the cooling tower. Now, as I alluded to before, the LSI, ultimately, the Langelier Scale Index, is kind of the gospel of where do we need to orient in terms of the performance of the program. And so, especially when we consider the use of RO treated water, we want to be careful about how much are we removing. And so what we ultimately ended up doing is blending that makeup water to a point where we could get full advantage of the RO water and the supply that came with that, but we could still keep that RO or that LSI index, I'll say, oriented in a nice balanced sense, but we even, as you can see on the slide, we erred on the side of corrosion to some degree, with a pH target of about 7.8, just to keep us clean. But the
So,
major
Patrick,
implication.
sorry for
Yep.
the interruption, but I need you to wrap in about 2 minutes.
I'm on it. Thanks, Ken. But that said, the key piece here is that we oriented with LSI to keep us balanced, but biological control was front and center. And to further support that biological control was side stream filtration, right? So we had UF, and we've got this fantastic physical barrier, but we needed that extra layer of protection, and that was accomplished through side stream filtration. Further, I'll say a suspender to our belt was the presence of a non-oxidizing biocide. If I remember correctly, there was a glutaraldehyde chemistry that was used, and ultimately that was used to keep that biological down. And if I recall correctly, that was something that we rotated over the course of the year. So we go from glutaraldehyde to isothiazolin, et cetera, just to keep the bugs on their toes. So in the spirit of Ken's well-placed introduction, if I can, I will just, if you go to the next slide, I think most of us will get these slides as a follow-up. So just to set these up, I won't speak to it, but this is a quick example where we looked at another application for a different refinery in the Midwest, an Ohio refinery, that was challenged with a variability in the water. And how could they use an RO system to recycle that water in the face of big swings in both chemistry and volume? So if I can, let's just punt forward to my last slide, the graphic in kind of the spectrum of what particle size and ultimately where different technologies play. And this is, if there's any shameless commercial, this is it, right? Again, you think of, given where we are recycling water, what are we trying to remove? What are we trying to achieve? What goal are we trying to accomplish? And typically, as my example, we see UF and RO as kind of go-tos, but certainly there's NF, there's ion exchange, et cetera. If anything, what the organization, the DuPont organization, focuses on that, which is orange. And certainly that's not all of it, but I think most of the opportunity that we see within industrial water reuse, but really recycle, as I've defined it, it lays within those orange buckets. So I'll pause there, as I expected and went over, but hopefully not too bad, Ken, to throw us completely off from our agenda.
All right, thank you, Patrick. It's a good meaty presentation, definitely. So
a lot of content. Thank you.
So I'd like to next introduce Lauren Hebert. He's with Sistemas Pol Viales. He's an architect and sustainable designer, and he'll describe how industrial rainwater harvesting and municipal water wetlands are adding resilience to Mexico's largest city, Mexico City. He will talk about rainwater collection, treatment designs, scale for large commercial and industrial applications, potentially, in some cases, cutting use by as much as 2/3, which is a terrific number. As well, also while water utilities are discharged into natural water treatment systems can produce recycled water for potable reuse, mitigating water shortages in Mexico City's historic wetlands district. And then I just sort of roughed in a number, based on Mexico City receiving roughly 30 inches a year rain, a 55,000 square foot roof of like a manufacturing facility would save as much as 1 million gallons a year. So the numbers add up pretty quick, don't they? All right, with that, Lauren, you're off.
Thank you. Good morning, everyone. Good afternoon for our European friends. Can we go to the next slide, please? Just as an introduction, as a context situation, Mexico City is an endorheic basin. So all the water that used to being collected within the basin used to form a series of 5 lakes. So with the passing of time over the last 500 years, we lost 99% of the surface of the lakes, and most of the flatlands became urbanized. So rainwater and wastewater have no place to be stored or regulated or managed within the city. It's very hard. So most of the infrastructure was designed to evacuate water as fast as possible. Speaking of rainwater and stormwater. And I'm sorry, just sorry, my guard. And sorry again. And then the water sources come from the aquifer, which has been depleted by 200% over the last 50 years. And we bring water from very far away, basins on the east and a little bit from the north. So basically the idea is how to manage water in the city, stop exporting water, stop importing water, and be sustainable. If we can go to the next slide, please. The city has been working on sustainable solutions for over 18 years. We had one of the first rainwater strategies for all construction except single housing. So every commercial, industrial, heavy residential, like multifamily housing, was required to do rainwater harvesting and reuse for non-potable uses, but it was not exactly or extremely well designed, because it was one of the first. So we have been working with the city over the last 5 years to expand and adjust this requirement, which is called Sistema Alternativo, which translates to alternative system. No? Now it's being implemented heavily throughout the city because we have now the experience and the technology to do this. No? Next slide, please. We based our systems with a combination of different theories. The first one, the basis was the German standard, which is using very simple rainwater filters, calm inlets within the stormwater tank, overflow siphons, and polluting suctions to get rid of most of the problems of the TSS and the pollutants in the water. But we incorporated specific and very efficient rainwater siphonic systems. You'll see in a bit why we use this. And we implemented an automatic first flush system, which we choose as a standard to remove 1/8 of an inch through most of the rain events, which we use as a automatic cleaning of most of the pollutants on the roof. You can turn this off during the peak rain season when you don't need any first flush, and you can bypass it during the dry season. We have almost 6 months in which we could not get good rainwater quality if we wanted, and we try to bypass this to any suds or rain gardens or stormwater destinations, so we don't pollute our rainwater tanks. And with these two combinations of very simple passive systems plus the diversion, we can rely on a very simple filtration system, which most of the times we don't require to go to ultrafiltration or reverse osmosis, because we have a very clean, very low TDS water, no? Because it's rainwater. It's fairly balanced. The pH is most of the times it's balanced once we mix it in our stormwater tank, in our potable water tank, and we just rely on filtration, some granulated charcoal and zeolites, ultraviolet, and chlorine for disinfection. Next slide, please. Very quickly, for those of you who don't use siphonic, I recommend it very much. These can help reduce the number of downpipes by a factor of 10. We can get the water to one point of the building where we want to have our stormwater or rainwater tank, and we reduce all the other pipes. We can have a very long no slant or no grade in our pipes, very small diameter pipes, and the water we harvest is the best water we can have. We choose harvest it in one point. Why do we have very small diameters? Because this is just the water that's been channeled through the pipe. The siphon allows we don't need the air to and the gradient to move the water. We just need the suction of the downpipe. This is very, very efficient for stormwater harvesting. Sorry, rainwater harvesting, and for architectural and design purposes is the best thing you can do. Next slide, please. Here you can see how we have no loss of height during the conduction of this water, the small diameter, and the reduction of downpipes. This is it's very fast to install, very cheap to install. And if we put a stormwater or a first flush diversion system in one point, it's very, very easy to control if we want to harvest or not. Next slide, please. You can see here, this is one of the case studies. This is a pharmaceutical packaging and manufacturing facility in Toluca. All the water is channeled to one point. In this case, we have a conduction above ground due to structural constraints in the small plot, but we have one point where we choose to harvest and send to our rainwater tank, or send the rest to the stormwater system. So it's very, very user-friendly. Just one button can decide if we want to harvest or not. And in this case, all the rainwater from this 70,000 square foot facility was used for cleaned and used for potable uses like hand basins and further treatment in the process, or also fire protection. And we reused the wastewater for toilets and irrigation, so we were 100% sustainable. During a couple of years, they ramped up a little bit more of the water use, but the combination between potable reuse of rainwater plus the reuse of non-potable wastewater, we managed to be 100% independent for a couple of years. And then we were between 90 and 95%. Next slide, please. This is this next project. This is in Yucatan. The Yucatan Peninsula has a very hard water. You need a lot of softening in the water. So when we harvest rainwater in this automotive part manufacturing facility, they use a lot less of their softening equipment. Most of these facilities already have some kind of treatment in their pipeline, so we just add to their original source water. And in this case, in the Yucatan Peninsula, it's great to harvest rainwater because it rains a lot, and the water that we get is much better than the source water from the wells or from the municipal supply. No, so it's very, very, very convenient and very cheap to use rainwater. Next, please. This is the way we use siphonic systems. We can have huge harvesting surfaces with a very, very efficient one-point delivery system. Next slide, please. This is another industrial case study. This is a beverage facility in which we harvest 40,000 square foot per warehouse, with a total of, depending on the sizes of the warehouses, 300,000 square foot forecast in the next couple of years. And we can harvest 18,000 cubic meters of potable water, which is used also for manufacturing and for the product production, because we help and we have much better water quality from the rainwater than from the wells, which are being depleted, of course, in the area. No? We will also have wastewater reuse for irrigation and toilets with a treatment wetland in the future. Next slide, please. As you saw in the first slides, just to not go over time budget. As you saw in the first slides, Mexico City was a city of wetlands. Everything you see in gray in the first image used to be a wetland. So we are returning the use of sustainable based solutions, nature-based solutions, to the city, and both of these systems are wastewater treatment effluent polishing wetlands. So we not only get better water, we cool down the atmosphere around the wetlands. We have an increase from 2 to 3 usual birds, which most of them are non-native, to over 60 birds who used this place as a former wetlands. Now they return, and we are recovering the biodiversity of the city. Next slide, please. So this is the images on the lower left. This is a former landfill. So we are building on top of a landfill, an old landfill. We built the wetlands, and we got an amazing response from the wildlife, the original species we used to have in that area. They return very fast, and they enjoy, and they use this place. So we are fixing and reusing rainwater and wastewater in both systems for the recovery of the ecology and sustainability of the city. Next slide, please. And this is a closing slide. This is one of the biggest rainwater harvesting systems we have done. This is 500,000 square foot warehouse in Yucatan. Thank you.
All right, thank you, Lauren. Great presentation. Nice differentiator between what Patrick did with the heavy industries, and then this is more manufacturer oriented. So now I'd like to introduce Kyle Gronowski of R3 Sustainability. He's worked in infrastructure and investment industry since 2011. He's overseen deployment of more than $1 billion in private capital, which is very impressive, Kyle. I hope you got a good margin on that. And those have been investments in transportation, energy, agriculture, infrastructure projects. And he's worked with a number of US and European-based firms for infrastructure investment. He graduated from the University of Denver with an MS in finance and BA in accounting and finance. And he's going to present on financing of water reuse projects. Take it away, Kyle.
Great, thank you, Ken. Thank you much, and thank you everyone for listening in. Could you go to the next slide, please? So I will point out very early on that my co-founder and myself, neither of us actually have water backgrounds, but as Ken mentioned, we've been in and around both the construction and infrastructure investment realm for over a decade each. And with Lindsay, our CEO, being more on the construction tech side, and with a number of companies and platforms, and myself being on the infrastructure financing side, largely with municipalities on toll roads and toll bridges, but also microgrid energy project as well. Could you go to the next slide, please? So as was outlined by a couple of the examples you all just recently heard of, industrial water reuse is becoming a main headline topic very, very quickly. Patrick mentioned that 50% of all reuse is performed by industry here in the US, but we still have a long way to go. And what's interesting to know is there are 75% of corporates out there that say they have water reduction goals, but 82% of those say they don't necessarily have a strategy, expertise, capabilities, know-how, etc., to implement those goals. And part of that is due to goals being implemented at the top of organizations, not necessarily all the way through. But another part of it is just there needs to be groups out there that can help industries come together with project partners and groups that can help them implement projects and goals. Could you go to the next slide, please? Another reason why, and I think we've actually seen some questions on this already, but another reason why industry is struggling to adopt, and where R3 hopes to help, is that, water projects in general typically do not meet capital budgeting timeline requirements of industrial players, and it's very difficult for large corporates to give exceptions to some projects versus others in terms of what project paybacks, et cetera, need to be. And as the chart here will show, and it's illustrative project that R3 is working on, is payback timelines are really in that 7 to 10 year kind of range. And certainly things can go either way here on the spectrum based on technologies used or the application. But at the end of the day, that type of timeline is very difficult for industry to accept and to really go out on a limb to make those investments. Additionally, historically, again, I'm speaking domestically here in the United States, is low water costs have made it so the idea of reuse and reducing those costs have fallen on the back burner, along with a lack of enforcement by regulatory agencies and bodies. But both of those trends are changing. You're starting to see very rapid rate increase requests by utilities, by municipalities. You're also starting to see a almost exponential growth in regulatory actions, which is in our view going to continue to drive reuse in the near future. Could you go to the next slide, please? So I wanted to again some case studies with more at a high level versus kind of what you just recently heard of in terms of a couple of projects. But where we think industrial reuse can really or industrial water reuse can really see some more adoption is implementing it in a way that helps solve other business challenges as well. So R3 is working with a chemical manufacturer that we found that water reuse is a strategy, is something that they want to implement, both from an ESG perspective, but also a resiliency perspective, based on local municipal treatment facility challenges. But the reuse facility could also solve other business problems related to stormwater drainage issues, relating also to river intake issues. So that we're really trying to look at water reuse as a way to solve multiple business challenges, while driving what we're all after here is reduction and reuse of water. In this particular project as well, capital budgeting requirements are completely out of alignment with where management sees the need for project paybacks, and that's where a group like R3 to help come in with financing for the project came into play. Could you go to the next slide, please? Similarly to the chemical manufacturer, working with a poultry processor, where the requirements to truck away sludge to land applications or to landfills is becoming increasingly difficult. There's been several cases where landfills have collapsed, and part of the view is that it's due to heavy sludge from food process waste and so on. And so again, in this instance, R3 is developing the solution with the client to not only reduce that land application to the to the number of about 60% in terms of the amount of truckloads required, but also to reuse some of the processed water downstream into the facility to reduce some of that initial water overhead, and to again do what we're all looking to do here and reduce this overall water consumption. Again, on this one, capital budgeting was another major consideration, and something I think we'll probably have discussions around on Q&A. Next slide, please. So, you know, it was mentioned on the last two slides, but what the R3 model helps to do, and, you know, others out there as well, is really reduce that initial upfront requirement when it comes to trying to figure out if reuse projects are even feasible, if they make sense for your facility, and so on. You know, a lot of groups can try to go down this path, and what we see is they ultimately stop because there's pretty heavy checks at the front end to try to see if you even have a feasible opportunity. You know, timelines are also something that becomes difficult when, you know, if you're starting from scratch, you can be looking at a multi-year feasibility study and understanding of if reuse makes sense. And, you know, a lot of times those types of projects, again, are tough to continue to push forward on, frankly. The CapEx requirement is probably one of the most major considerations, based on the fact we just came out of COVID and so on. You know, companies are looking at capital projects differently. They're looking at cash differently, operations differently, and really where, you know, R3's again hoping to help is we can provide that CapEx and eliminate that capital, you know, budgeting requirement. And, you know, one aspect that seemingly gets overlooked in a lot of water projects is working with stakeholders. I think, you know, Patrick mentioned it quite well in his discussion, is of how to, you know, partner with nearby facilities, but there's also, you know, stakeholder groups that are related to the treatment system, you know, making sure we're not causing special groups to get, you know, really high rate hikes, for example, because we take a lot of substantial fluent stream offline. And so, you know, doing that more fulsome approach, we feel is a way to ultimately get projects across the finish line. And finally, leveraging insurance and financing instruments, if you will, to make sure we can utilize innovative technology. As we all know, you know, water reuse is evolving every day, and it is very difficult oftentimes to stomach the ability to try something new. And so, you know, there are products out there to say, you know, we can actually fund and finance new tech that might work best for your particular application. And with that, I think time we can open up for Q&A, or I'll let you do that, Ken, but that's all from our standpoint.
Great. Hey, thank you, Kyle. Great presentation. I really liked how it rounds out the discussion today, because I do think financing and rate of return on investment is something that holds back a lot of projects. All right, so I think now IWA staff is going to release the poll questions. At the bottom of your screen, you should have a button. I think you can access those. I see them popping up here now. And at the end of our presentation, at the end of a Q&A period, we're going to go ahead and show the poll results from today. There's just 3 questions, and they'll take you 10 seconds each to answer. So if you could do that, I think you'd all be interested in how that sort of shakes out. Okay, so we had a couple questions that will remain unanswered from during the presentation, but and Patrick, I'm not sure, I don't see you on anymore. 2 of them were directed at Patrick, but I do think, Kyle, the second question on financing, you can address that, as well as the third one's addressed to you. So why don't you go ahead and hit those 2 questions? Maybe state the question first and then your answer.
Sure. So, the question being that do industrial customers struggle to achieve acceptable return on invested capital for water reuse projects, and, you know, what options should they consider to close the gap and be able to adopt technologies within the segment? So, you know, the answer is absolutely. These obviously it's company dependent, but I think broadly speaking, water reuse projects are extremely difficult to line up next to other capital budgeting projects, and that's where leveraging different financing options. Groups like, R3 are out there to, help you look at those options to figure out models that ultimately can make sense for industrial customers, and allow it so that there's no capex. So when you're looking at the acceptable return, it's really a cost line item versus a return on investment. And as it relates to the adopting new reuse technologies, again, mentioned there are products, insurance and financing projects that can really help support that.
Great, good answers. And I'll just say, certainly been in my experience that most industries look for returns on the order of 2 or 3 years, but the groups like yourself that you have there can help bridge that financing, allow and return that's not that aggressive, but so allows the project to go forward. So I really like the fact that that option exists there. Patrick, I see you are on. Can you answer the first question?
And I'm on, and I'm being cautious by keeping my video off because my connection's getting a little wonky. But I'll certainly
Okay, I thought you
do
just
my
said
best to
you
answer
showed
the
off and you
questions.
couldn't show us. Okay,
Yeah, no worries.
go for it.
Yeah, well, listen, there's one question just in terms of managing the brine. We manage that as we would, that we basically went to the sewer, right? We managed it the same way we were managing the cooling tower blowdown and continue to manage the cooling tower blowdown. And I think if I can jump to the next question in terms of regulatory policy, I think it's one of the things. It's I don't think it'll persist forever, but at a high level, municipalities have to deal with a lot more than industrial facilities do when it comes to regulation around water recycle, water reuse. And I think if certainly the regulations that hit the industrial customer typically come in closed loops where maybe there's blowdown that is, let's say not where you don't have it going to the sewer, you've got it going to a body of water, or potentially where that water, as it's recycled, especially municipally treated wastewater that's being recycled, if there's a potential for contact with humans, with people, that's where there's more regulation than really where there's any regulation. But Ken, if you'll allow me, I'll jump right to Joe's question, just because I know Joe is going to just load me up. But if I can do my best to answer it, in terms of the return on invested capital, a little bit for the water reuse or water recycle projects, ultimately you're right, it lands with an ROI in the neighborhood of 2, maybe 3 years. But in the case of the refinery in the Midwest, the costs were greater than the cost per kgal for makeup water or for that supply water. It was really about enabling a very needed, almost a desperate expansion to the capacity for that refinery. So as much as it was viewed from that lens, the typical ROI metrics went to the wayside.
Okay, good answer. I would like to kind of add on real quickly on the disposal of the RO concentrate, and you gave us what the actual scenario was in your example. But I would say that, there'd be a lot of times you can't go to a municipality because they have certain limits in their TDS. Certainly that's true in Southern California and the Southwest in general. So instead, I really think there ought to be more of a program of disposing of deep well. I do not believe whatsoever in drying to salt with a crystallizer. I know there's some people probably on the call here on the webinar today that work in that field, but because when you dispose of the salt to a landfill, 10 million years from now, that salt's still going to be salt. It doesn't decay. Radioactive materials decay, pesticides decay, but salt doesn't decay. It's going to outlive the landfill liner and it's going to go to groundwater. So I think instead, what we really ought to be doing is leaving things in a liquid state brine and injecting deep well into a geologically stable formation. That's the way to get rid of it. Or if you're near, of course, the ocean, you can go there potentially. But I think taking concentrated salts to like lakes or rivers and stuff, freshwater sources, is something we really should be avoiding. That's my little soapbox moment. Okay, so we had a few other questions that were provided ahead of time. And we'll field a couple of those, see how that goes. All right, so one of those were, are there any new trends in near ZLD or ultra high pressure RO applications? Patrick, why don't you take that on? What do you know about that?
Yeah, no, and this was the, I think to some degree it speaks to the second example that I was trying to sneak in. Within DuPont, it's, we have our version of a closed loop kind of high recovery RO, and I know there's certainly other providers of similar technology, but that's the first step, right? In terms of getting as much of that water, let's say reducing the brine stream as much as possible prior to getting to a level where you're going to evaporation crystallizers. That I think is the most readily applicable, readily deployable technology. Though there's companies like Saltworks, there's companies like Heartland that take let's say a less conventional approach to further squeeze that brine stream. And even I think Saltworks, for example, we were talking about the example of a landfill. I know, and that's Saltworks, Heartland, sorry. But Heartland, they use basically readily available fuel to power what is a fairly robust device. So I won't steal Earl Jones or any of the Heartland's team's thunder, but I think there's a lot to choose from. But as you go, let's say the more you squeeze that brine, the more expensive it's going to get. So I think, again, to redeploy to the readily deployables, that those high recovery RO systems.
Yeah, and I do think, and that's a good point, TCRO is not particularly expensive to deploy. You can use a pretty common facilities for that, or high pressure, but things like forward osmosis and other more exotic technologies, and those are also energy hogs. And so there is decidedly some very ungreen aspects of trying to recover that water, because all that power comes with the water energy nexus at the power plant, that you don't always account for. So good. Next question we have was, does Israel lead the world in water reuse? That's my understanding. If anybody else on the group wants to chime in, and you're welcome to, but I do understand they are pretty much the world leaders now. Okay. Do you see applicability or growth with zero liquid discharge in industrial water reuse regimen? So, I mean, I have, Micah, first of my 40 years, my first, 20 out of the 40 years, internal reuse was very, very limited. And I would say 90% of our projects was more about treatment for discharge. Now, 90% of my projects are treatment for reuse and recovery in some way internally. So definitely the script has flipped in industry over that. But as far as going to zero liquid discharge, there's different ways of defining that, like a solar pond. That's not hard to do, and it's energy efficient, very green. But crystallizer, evaporator, those are very energy intensive. So, and then, like I said earlier, I don't believe in going to salt anyways. I think we should leave it in a liquid form and dispose of in a geologically stable formation as the way to get rid of the high salt waste leftover. Okay. Next question. How much is going to cost for enterprise water reuse technology equipment? So would it be expensive? How about you, Kyle?
It's very much project specific on everything from pumps to process, whether you can have containerized units versus the full-blown spectrum of projects like what Patrick and Lauren shown. So I think that it's going to be expensive, but there's where I think industry can evolve, as you saw in the energy industry with solar and whatnot, is partnering with financing options that can really help you mitigate that upfront cost.
I have a question for Lauren here that we had earlier, and that is, Lauren, your last slide, you said Mexico City has potential to harvest and treat 50% of its water needs within the metropolitan area. Do you know if the Mexican government has any plans to act upon that? Are there any Mexican laws that are promoting reuse at that scale?
Yes, there is actually a big plan of restoring the former lake bed of Lake of Texcoco, which was it's a almost 14,000 hectare lake bed, which was going to turn into an airport. So it was recovered and it's turned into a natural protected area, and it's going to be turned into a stormwater regulation basin and wastewater treatment wetlands. In the next few years, there's a second one south of the city, which is a very big system, 1,000 hectares as well, which we are working with water reuse and the RAP from the EPA also as an advisor. So we are closely, well, the reason why we are here is because of the Water Reuse Association, but we are working on big projects within the Mexico City Basin for reuse. And what I meant with the potential of 50% reuse is that there's enough land and enough wastewater close to each other for this purpose. So there is a plan, and over the next 10 years, it will be.
That sounds great. So it'd be interesting to see how it gets implemented.
Yep.
So a couple other quick questions we had ahead of time. Is there a pathway on direct potable reuse for industrial facilities in California? I thought there was a direct potable reuse project in San Diego area that CSM Hill did. That would be municipal, not industrial. Obviously, the municipality may receive some industrial waste, but I believe that is a direct potable reuse project in San Diego area. That's something I want to know about offhand. Anybody else on the group here know of any other direct reuse of industrial wastewater for potable? Yeah, it's a liability issue probably, is because it's one of those things to get over. Okay, then this is a great question. This next one is, which industries are forerunner implementing ZLD practices in North America? And I listed a lot of industries in this one slide I presented on that are doing industrial water reuse. But which one is the largest forerunner is a good question. And then ZLD, that's asking a lot. Let's just say, reuse, right? So, I kind of would have to hand it to, in my opinion, municipalities, right? They're doing the treatment, they're making it available for industrial water reuse, and they're at a very, very large scale. I could tell you I'm doing work right now on a mine in Peru that is treating city wastewater, sewage, on the order of 40 to 50 million gallons a day. 2/3 of that treated water goes to the mine, 1/3 goes back to the river. That's the deal they struck, and the mine paid for all that treatment. That's a pretty good deal, and I could see that model being done. In fact, it has been done in a number of areas around the world. And it's a good model because it provides industry the water source they need, and it provides municipalities with some financial relief on getting things built. Anybody else have any other things along that
Ken,
line?
I would just add, right, I think there's two basic drivers that I think the kind of land with food and bev, for example, but one is around necessity and the other one is around brand, right? And that brand might be wrapped in a sustainability or ESG label, but mine, I think you call out the mining industry and maybe even some cases produce water, upstream oil and gas. It's out of necessity, right? But otherwise, I think brand is driving a lot of the work. You think about what PepsiCo or ADM Budweiser talks about in terms of their water consumption. That's a big part of their brand, and if they're going to get there, they have to recycle water. Yeah.
I did some work at a Coca-Cola facility about 15 years ago, and that was recycling some of their waste syrup actually, but for wastewater treatment at a municipality. It was a great application. All right, got to move on. Last question was about recycling, flow back and produced water. Will that be discussed? That wasn't part of the presentation. I can tell you though, obviously it is done. Very high salinity in most cases. So you don't usually try to go all the way to fresh water, but you can do a lot of reuse within oil production through reuse of the produced water for additional use within that same industry. Okay, so Isabella, why don't you go on to the closing slides? Oh, poll results, great. Okay, so the first poll question was about the typical amount of recycling directly. So the highest number is 50%, but I guess the average of those, yeah, the average is probably also about 50%. Yeah, and that's not too far from the truth, I don't think. Okay, next question. Oh, we scroll down, excuse me. Okay, you can scroll down. I was just, all right. The second question, how do you feel about government's best support? So the biggest was all of the above, which I agree. I think that was, you know, that makes the most sense to me as well. That we really need a multiple prong attack to really help get this off the ground. And then the third question is, and this is you could do multiple choice here, and the biggest was the capital cost demands in terms of the most significant deterrent. And I agree. And gee, Kyle, that's where you come in, don't you? Okay. All right.
That's the goal.
All right. So now, Isabella or Dr. Espinola, please. Thank you. Okay, so closing slides. So there's a upcoming webinar next week on modeling and mitigating nitrous oxide. So if you're interested, navigate to that. Next slide. And then we also want to mention the World Water Congress in Copenhagen in September this year. And they're taking early bird registrations now. So if you're interested in that, navigate to worldwatercongress.org and sign up. And then lastly, I think, yes. So then also there's a, the suggestion to join a network of water professionals. I think you will find a lot of good discussion in these chats. You'll learn about more webinars like today. They're offering a discount to sign up. So if you're interested, please navigate to iwaconnect.org. And then last slide, I think. Thank you very much. So I think we had a great presentation group of presenters today. I really like the fact that it was very well-rounded with heavy industry, manufacturing, financing, a lot of good questions. Thank you all the audience and our presenters, and to IWA and WATEREUSE.org.